Good evening, everyone. Welcome to the live stream. Okay, let's first tone down the music a little bit. I don't know. I should make presets for this, I guess. I don't know, like this. Now I almost don't hear it, but I think it's loud enough on your side, so I'm just gonna raise my volume in Windows. So, well, not a lot of people here yet. Philip was definitely first. He was 11 minutes too early. For some reason, I am first. And then Dutch Maker is here. And then Greg E. And Dutch Maker says, yeah, music. Oh, and Johnny Bergdahl is also here, but he wasn't first. Evening all, says Medved. And Sevag JB is here. Nice. Today we're going to continue working on this guy. I just polished it so it's nice and shiny again. And in the pre-stream we're actually going to hook it up, because I've been running some software that's available for it. ESP Control, I believe it's called. And it gives you some home assistant things. So in the pre-stream we're going to play with that a bit, and then after the pre-stream we're going to continue designing, doing stuff I haven't done before either, so that's going to be interesting. Johnny was looking for his pink tutu. Okay. I've had some issues where it wouldn't boot, and that might be software related or it's hardware related. I have no idea. So like right now, it's just black. It's on. Okay, you can't see that, but it's black. I can try the other USB port. Nope. It's on. You forked ESP control for other display boards. He will not accept your PR? What? Oh. Okay. I don't know. For some reason I have to try this a few times and then it'll boot. I mean, you can't really... Yeah, there. You can see it's on. If I do this, it's off. So... I don't know why. Dinner is almost ready. Aw. Pre-stream was early today. Yeah. I had a lot of annoyances today. I've been moving Quinn LED and other domains, and I got stuck in it for hours and hours yesterday. Turns out that my current host, their web interface, is just shit. It says transfer lock disabled, and this is your transfer code. I put that into the new host, and the new host says, nope, transfer lock is enabled and the code doesn't work. So after hours and hours of trying to get that to work, I finally emailed the new host, and they said, oh, you're trying to move away from TransIP. Yeah, their codes are probably all wrong, and their transfer locks are probably all engaged, but they just don't show you. And there's no refresh button in their web interface or something like that. So I then emailed TransIP again, and I said, look, I'm trying to move away all my domains. Please let them go. Refresh your information or whatever is going on. And today they said, oh, I'm sorry. It seems you were out of sync. Out of sync? What do you mean? Anyway, they synced everything up again, and now I'm finally able to move away all my domains. So I did some price comparisons, and I believe TransIP is asking me for like an NL domain, like $19 a year, and I've moved to main.host, and they're asking like $5. And I have about 80 domains, not all NL. I also have .com and .tech and .info and all kinds of crap. And just that alone will save me, I think, 1,500 to 2,000 euros per year. And then the hosting, I had a lot of individual hosting packages with TransIP, and their cheapest one was $9.99, and I believe they're bumping that up to $12.99. And some of them I needed the more expensive ones, so that was $20 a month. And now I have one hosting package which hosts all my websites, and that's $15 a month. So it's cheaper than one I had before for all of them. Instead of I had the 8 I had before, I was paying like 100 or $120 a month just for the hosting. I'm now paying $15 for the same thing. So yeah. No. Mine.host has a different philosophy. They don't give you a discount for the first year, but every year is the same price. So every year is $5 instead of $20. I don't know Neostar. Yeah, Transipay used to be good, but like a lot of things nowadays, they got bought up by an investment company. And I've basically decided anything I use that is bought up by an investment company, I will leave. Because enshittification is real. If it's bought up by an investment company, it's basically bought to squeeze dry and make more money than they put in. And if it dies after that, that's fine. So yeah, that happened at Transipay. They've since I was there, they raised their prices 250%. While their costs certainly didn't rise by that much. I mean, a domain without a host, because they don't even give you forwarding or email if you get a domain, it costs like $4 at the registrar, and they charge you 20. Just pure profit by doing nothing. And so MineHost says, okay, well, it costs us $4, we'll charge you $5. Okay, I can live with that. Yeah, so services that start out cool and are nice to work with, then get bought by investment companies and get ground into the ground, grounded into the ground. I don't know. Yeah, this isn't working anymore. Maybe I should try a different USB plug. I don't know. And I mean, they're just money grabbing hogs now. Same happened with VMware, for instance. Excellent software, and Broadcom bought it and just destroyed it just to squeeze it dry. And there's some other services I used to use in the past. Same thing basically happened. Got bought up by an investment company. Totally screwed. Exactly, Philip. They are blocking me from moving. That is correct. Yeah, by showing me that transfer lock is off in their own web interface and what my transfer code should be, but those are just bogus. They don't relate to anything. And now I had to bother them by email the whole day long, and now they actually synchronize them with their own database. What? And now they're working. Oh, come on. Oh, it was displaying something? I didn't see anything. Oh, I just heard a disconnect sound, but this is not connected to my computer, so that's interesting. It takes a lot of code to fake that data. Yeah, it's just stupid. I was a client there for, I don't know, since 2016. And now I'm gone. I mean, saving $2,500 or $2,000 a year, that's worth a day of my time. And I asked Claude AI, to help me out, and he did a lot of the work for me, especially converting WordPress installations and things like that. Today I moved blog.quindorian.org, which was my intermittent technology blog, to blog.intermit.tech, and Claude rewrote like 10,000 lines for me, including all the links in my articles and redirects on the old website and all kinds of stuff. Yeah, this isn't working. Maybe I'll try and connect it to my computer. Maybe that works. Good evening, Master of LED. No DNS HA. Okay. This used to work. I don't know why it's now not working. I played around with it a lot. It was working once. Okay, yeah, okay. I didn't see it. I guess we'll just keep replugging it. Oh, this cable's really bent. Okay. Yeah. Well, we can see the power usage now. If I can get it on the screen. Somewhat. There. Okay. Okay, let's try this port. I heard it enumerate, so that's good. Oh, there it is. No idea. Now it's upside down. Okay. Okay, so these are the lights in my office, so that's no good. But I believe there is now a web interface. Let me connect to my router. My router says it at 1024. Okay, let me get that IP. 1024.1. Okay, and let me share that browser. There. So this web interface then you can access. It's running on the device, and you can add buttons. Oh, now I need to have something from my Home Assistant. Hold on. Let me go here. So what device is my... Copy. Okay, back to the other website. There. I want a light, and I'll type colored. See, okay, sure, light. Do I have something else? No. Okay, I can only select color temperature, and we're gonna change this light. And for some, I want. Okay, let's make it a switch. Okay, what did I define the other? This one. Yeah, this isn't working. Oh, edit. Slider. Okay, I want a slider, I guess. Okay, new. No, edit. Jesus. Slider. Entity. Sure, save. Apply configuration. Uh-oh. It went all wonky. Oh, is it booting? Yeah, there's some kind of weird interference now. Okay. Let's reboot it. Hey, Draadstal. Is it gonna boot again? Screen slowly went gray. Yeah, I don't know. Maybe we wrecked it at some point by taking it out. Did we take it out? I don't even know. I don't think we took it out. But it's been... Oh, okay. It's been misbehaving. But once it boots, for me, it just kept working. So, okay, now it's drawing a lot of power. No. Is the web interface working? No. Yes. Okay, so the web interface is working. I just don't have a screen. Okay. Is my screen broken? Is the screen just not seated correctly, maybe? Should we try and mess with it? Let's try and mess with it, because it is booting. The screen just isn't working. So the best thing is to mess with the screen, right? That's what you should do. Okay, so we're going to take out this clip here. I don't... Oh, it's a clippy uppy. It's a uppy clippy. Right? So we unclipped it. So let's take it out. Okay. So this ribbon cable only has pins on one side. The other side's black. Okay, sure. Let's blow on it. Cable too long. What cable is too long? It's their cable. And now we're gonna try and get it back in there. There. That seems well seated, but I'll push it a little bit in. And now we close it again. Is it a Nintendo? Okay, I think that's in straight. As far as it goes. I don't think anything happened here, but you know, I can push on it a bit. There. Okay, let's see if that did anything. Yeah, it's some kind of booting issue, but I'm thinking it's more I'm hoping it's more software than hardware, really. But out of the window, fail. Let's see what it's doing. Maybe. You made different version? Yeah, that's the one I'm using. Yeah. I haven't installed an update. Maybe that would help. It's not helping. Let's try it again. Pre-stream is over. We are live. Okay. You know what? Let's just flash it. See what happens. Okay, I'm on the website, and you can select which type of panel you have. Install, go, whatever. Do it. Install 2.1.2. Yeah, that sounds newer than what I had. Does it say what I had? No, of course not. Erasing. Okay, it's gone. In the meantime, we're going to be drinking pineapple grapefruit, 0 sugar. It's one of those tastes I like sometimes, but not another time. I don't know. Right now, it's okay. No clue why it's installing this slow. It's like using the internal serial device, I think. So. Let's brick it more. Yes. Check for serial. No, we're beyond that point. My week was very busy. Yeah. I made a new website. It's not really done yet, but I decided I needed a prettier website for the DigNext controllers. So I made dig-next.info, and it has some nice pictures and photos on there. And you can go to the DigNext 2 and you see the nice DigNext controller, and one of those more flashy, fancy websites with there's like information there, but not really one of those. Well, you already have QuinLED.info, which has like all the technical information, right? And yeah, it has all this stuff on there, and it has this cool graph I had AI generate for me, and some really nice fake LED showings. Like this is all AI generated, and then my video, and you can get some questions, and yeah, I'm hoping that'll attract some people who otherwise, wouldn't find or look on QuinLED.info. It's more of a flashy front site than the real site. Then again, if you want to go to the wiring guide, It's right here. Oh, I installed cookie thingy on my website, so accept. I don't think I have cookies, but maybe. I just want to dig-next.info. And yeah, it has all the resellers that are currently there, so I can go to the Queen LED. What? Oh, okay. Of course it's broken when I try and show it. I can go to the Dutch shop, or I can go to Dr. Z's, or Allnet, or Jerem's, and there's going to be more soon. And yeah, it's just a nice, where can I buy it? How do I get help? Install website. It's just a nice overview website for people looking for a controller, but not so much the deep technical information, right? And it's probably also going to help with AI search engines and normal search engines and normal people, I hope. So, yeah. So, yeah, I think that's good. I think that'll help some people, maybe. And I'm hoping there will be a DigNext 4 and a DigNext 6 at some point, so I had them added so I can, keep the same website alive. Oh, let's see how the firmware is. Oh, the firmware is complete. Let's log. Boot seems... Okay, let's reset the device. Okay, the MIPI setup is complete. Oh my god, what's going on? Okay. Holy logging. Let's go back up. Did it set up the display? Yeah. Setting resolution. Setting resolution. Visual setup start. Okay, well this is definitely newer than I had, so that's good. Yeah, it's an ESP P4 Rev 1, okay. Yeah, the transparent, it's a bit too transparent, huh? How do I do that again? Ooh. Filters. Color. Opacity. Like, I'll give it a bit more. Oh, wait. Now it's gone? What the... I don't know what happened. Oh, there. There, now it's almost not transparent anymore. Anyway, yeah, the screen should be showing something like connect to the Wi-Fi. It's not. Let's try this this cable again. I think it's there though. So I just got a broken screen. That's not boding well for future longevity. Let's see if there's a Wi-Fi. Yeah, the ESP control is there. Yeah, okay, I don't want to go over this right now. So I might actually have a broken screen. I don't know, let's push on it. Thanks, Foxionaire. Yeah, that's the idea. It's not to replace or anything weird like QueenLED.info. That's going to be the main site still, and it links back to that. But yeah. Nope. Okay. Oh, that sucks. I wonder if it's broken or if it's software. What do you guys think? Is it broken or is it software? I mean, no, the backlight is working. The backlight is turning on. You can't really see it, but if I do like this, right, the backlight turns on every time. And the web interface comes up and the Wi-Fi comes up. So I'm not really sure what's going on. Maybe now we know why they're so cheap. Yeah, because the interface is directly from the ESP. No, I tried the... this is the other port I just tried. It doesn't seem to change. Yeah, there's not... I mean, the pins go directly from the ESP to the screen, so there's nothing to do there. I already reseated the connector. I have two. The other one is with the Ethernet. But I use this one to flash the firmware. I think the other one might be here. I don't. Oh, here it is. Yeah, here's the other one. This one still has the plastic on it. Well, I guess we can flash this one and see if it comes up or not. I don't know. We're going kind of, you know, on a squirrel here. Well, I mean, with the default software, it boots immediately. Uh-oh. I think I actually saw the screen corrupt. Is it just not that great? Okay. Yeah, okay, that's because of power, probably. Okay, let's flash this one, and then we can compare. Uh-oh. Now this one's dead, too. No, okay. Hey there, Nigel. Install. Oh, wait. You can't see that? There. Yeah, I know. Try again. Okay. Yeah, install. Yeah, no, I'll try and find the default software later. It may be a bad connection, I don't know. Not so much on the USB, though. That USB is fine. Okay, so today, I think we're going to look at PUE solutions on LCSC and see if we want to do a dedicated PUE circuit. So we build the PUE ourselves. I kind of want to look into that. Or we will use one of those pre-made PUE modules, which would make the whole thing a lot easier. Because I've never built a PUE circuit, so that's going to take a lot of research and tries and probably a few prototypes to get it right. But, you know, try and heat the board? I don't know. You think it's like a broken pin or something? I don't think so. Where's the connector? Over here. Pins look okay. Well, I guess you can't really tell like that, but yeah. Can I get closer? Yeah. Yeah, those pins look fine. Yeah. I don't know. Works perfectly for a few weeks now. But what firmware are you running on it, Michael? Yeah, that's what I'm thinking too, Greg. Once I do it once, I can do it more often, right? ESP home. Okay. Yeah. Maybe I got a dud. I don't know. It worked for a while. I played with it. Wrapping up. Well, let's see if this screen turns on. Okay, well, this screen turns on immediately. So let's try and boot it. Clicking it pauses the stream. What? Yeah, I wasn't so much as looking to use ESP control, but I wanted to have something to flash on there, and I saw they announced that they now support it, and was like, okay, let's give it a try. So, maybe this one? Oh, I now understand what Philip meant. Okay, so now this one seems to boot with the screen just fine. Maybe it's the USB connections, because this one... No, okay. No, okay. I thought it was very janky, but I can even pull it out a little bit. Yeah. Yeah, okay. Let's see if we... Okay. We're still squirreling. Let's see if we can find a hot capacitor or something like that. Of course, you'll see now it works. Because the screen is turning on, but it just not displaying anything. So that's the Ethernet chip, I think. Let me check. Yeah, that's the Ethernet chip. That's expected. Yeah, that's the weird thing. There is nothing connecting the screen. There's nothing... I mean, the screen connects directly to the P4 module here. Right, let me turn on an option here. Yeah, but the backlight is on, so I don't think that's the issue either. Something is slightly warm here. I believe that's one of the power management ICs. So that's fine too. Nothing that jumps out at me like, okay, this might be wrong. Let's see, on the ribbon cable itself. Nope. Yeah, nothing that says to me like this is wrong. Could be, but the backlight is on, right? So if you look at it like that, oh, you can actually see it flicker. The backlight is on, so if the backlight would be off, sure. Yeah, but, I mean, there. Okay, well, I don't know. Maybe I got a dud. It can happen. Right, so, no, let's go to this one. Oh, there, LCSE. Time to bring out the microscope. No, we're stopping that for right now. Oh, the backlight isn't controlled by the screen driver. Yeah, maybe. I don't know. I'll figure it out. I'll try some different software on it and see if that works better. Oh, wait. I need to sign in. Sign in. Don't look at my hands. What? I'm not a robot. Why does it think I'm a robot? Okay. Let's search for a PoE. I don't know. Okay, that doesn't tell us anything. Power over Ethernet. Power supplies. Okay, what's that? Power over Ethernet controllers. And we also need some sockets. Right? Because the sockets I use right now, they're from London, I believe. What's it called? London? It's not in there. Why not? Okay. Is it the wrong sockets? I want one socket with LEDs. RJ45 in stock. Okay. There is only non-PoE. Okay. That's not going to work. Let's search by price. Yeah, okay. Then we get the really cheap ones. I want integrated magnetics. Oh, here's 100. Okay. So the ones I use right now, I use... no. No. Also no. What? Let's take away this. Let's take away that. Oh, cool, Dutch Maker. Yeah, I'm trying to find the socket I use right now. But for some reason, that's not showing up. So, something is preventing it. Ah, here we go. I've noticed that before in LCSC. It keeps the search term in there, which is totally bogus. With LED... Okay, yeah, let's give it the shielded. And then go to 100, in stock 5, okay. Yeah, I believe this is the one. No. Okay, I'm gonna look up what I'm using on my latest prototypes. Hold on a second. One moment, please. Maybe it's in a different category, so that's why I want to know. I am using this guy. No clue why we weren't finding it. Oh, jacks with magnetics. It's a different category. Ah. Okay, good to know. Yeah, let's not go to the Chinese part there. Right, so jacks with magnetics. Okay, and I'm using now the upper lip version. It's a little bit more expensive. But I think on most of my boards that works better. Yeah. Okay, let's go. Modular Ethernet jacks with magnetics. I need a single port with LEDs, shielded, with PoE. 20 results. In stock. 12 results. Okay. And let's sort by price. Oh, okay. Oh, and 100 actually comes out on top. Interesting. Nice. And that is a lower one. I'd rather have a upper one if they exist. Yeah, but I'm not going to pay $10 a piece. What kind of price is that? Oh, you want to pay $10 for your Ethernet connector? Yeah, sure. Okay. What's the difference between this and that? Or this one? Oh, this link PP. Okay. So let's see. We have this guy, 10100, and this guy also 10100. Okay. What's the difference? Let's look at the schematics of the connector. Oh, this one has internal diodes, it seems. Okay. And this one does not. It has the capacitors and resistors. Huh? Okay, so this one, PUE applications. PUE applications. Okay. Interesting. So why does this one have the diodes and this one does not? Let's see if the text explains anything. This a connection to the shield? No. Yeah, this one has a shield connection. Oh, and this one doesn't, but it has a shield, so that makes no sense. They both have a shield. But I guess this one has the 1000 PF integrated, and the resistors and capacitors. And then this one does not, but it has the diodes integrated. That makes no sense. I can't imagine it doesn't have the shield connection. So this one's UL recognized. This one is not. I don't care too much about that. Pin 14, 13. Yeah, this doesn't have a pin number. Okay. This one's designed for 57 volts, 350 milliamp per center tap. Okay. And this one is not. 1500 volts, 2250. Okay. Let's take a look at the one below that from Link PP, see what they say. Oh, this one's for gigabit, I think, because it has 4 of them in there. This one also only has the capacitor and resistor. 80, okay. Yeah, this one's for 1000 BT, so we don't need a gigabit, so that's a bit useless. And these are just way too expensive, so we're not going to use that. Actually, now that I think about it, the way it would work on the module, we don't really want a cable plugging in like that or like that. We want to plug a cable in like that. Right, so standing up basically. So none of these will actually work. Yeah, like this. No, also, yeah, like this. So you have the pins on the back, and then you can plug it in from the top. But not if it's going to cost 11 bucks. Okay. Let's remove this and this. $11 a pop, why not? Yeah, exactly. Okay, without PUE, we get a lot more options. But I've got extra trans IP money now. But if I ever want to make this a product and actually sell it, I can't use components that are $11 a pop. But yeah, we need the PUE pins. See, this one doesn't have those. Yeah. Is it vertical then? No, I don't want surface mount. See, this is why I generally don't do this on stream. I spend days doing this for a project. Long, very long times. Because finding the right components is a lot of the work. And I'm sure it's out there, but yeah, it can be hard to find because this one, okay. Because also on LCSC, their searching and sorting and stuff like that is often wrong. So going through it like this and seeing what pins it actually has, you can actually find sockets you wouldn't otherwise. Like, let's try this one. Yeah, no. 11 pop for that CEO. Nice. Thank you, Draadstal. Huh, I had hoped searching for a connector would have been easier. Do we have to use external magnetics? Let's see. Modular Ethernet. With PUE. 3. Okay. It's plastic. Okay, so going for one without magnetics, I guess then you need magnetics with PUE extraction or something. Okay. Go for, okay, let's try that. HY9311. Yeah, but I'd rather have it angled upward. Yeah. Sure. This one has the diodes in there, but I don't know what the difference is between the diodes in there or having the capacitors in there. I think having the diodes in there would be beneficial. But I just don't know the difference. I guess, you have to do the diodes yourself, and maybe the diodes take over the function, but then you don't have a shield. Yeah, but this one's like designed for 57 volts and blah blah blah. I don't know. Okay, well let's table that for now. I'll add some of these to my cart. Yeah, sure. I guess that makes it easier. Let's add some of these to my cart, and then we can take a look at them later. Because the next thing we need to find is an PUE controller, or no, we can use something like this. So you have these modules. They're quite expensive. They're fairly expensive, but they would make the design a lot easier. And if I'm doing like 100 to 200 boards, using something like this would speed up the design and be okay. But if I'm doing like 500 or 1,000, or I want to use it more in the future, it's, I can do it better myself. But you have these modules which you just plug into your PCB. Now, I kind of want to look at it, designing it myself, because I can use it more in the future. But also, this module is about 4 centimeters wide. And I'm not sure we have that space. Maybe in the middle, because it's, a round opening. But yeah, I don't know. So let's look at PUE controllers. And let's just go by in stock and then sort by price. Now, someone mentioned a chip here. The Psi something. Okay. Let's take a look at that first. The B, I believe. Why does it do this? I just want to know. Okay, it's by Skyworks. Cheap? It's not cheap. It's $2.50 just for the chip. Full PD interface, low EMI switching regulator. Okay, so it also does the voltage conversion. It never worked without overheating. Yeah, and I don't think he did it the right way. I don't know if I want to do it the right way or not. You can do it the wrong way, and that is doing it non-isolated, or you can do it the right way, and then you need full isolation. Now, in my opinion, I don't think we need to do it the right way, because whatever we're building will not have an electrical connection to something else. And if you do have an electrical connection to something else, you need isolation. If you, for instance, look at the PUE Olimex boards, because they design nice boards. They have an ESP32 PUE, and that just has like a buck converter on there and a little PD negotiation chip and stuff like that. But it doesn't have an isolation transformer on there. And they have a different one. The PUE ISO. So, and that one does have isolation on there. I think it's this guy. I'm not sure where the isolation is. Do you use the ISO version or the normal version? Because this one's a lot bigger because it has the isolation, right? Well, not a lot, I guess. I don't. A bit. Yeah, you don't need it because it's self-contained. So that's what I'm thinking too. These touch panels would be on the wall and doing all kinds of functions, but they wouldn't really be electrically connected to anything that would have an outside power source. So like the sensors and the touchscreen and even buttons you connect and anything like that would be powered from the screen. There wouldn't be an extra power source to connect to the board, right? So I'm wondering if we would need isolation. Anyway, let's go back to this chip. Okay. Integrated switching regulator with power on, dual current hot switch. Okay, so it has a lot of stuff built in. Okay, well, don't need gigabit, but okay. Yeah, but $2.50. That's a lot of money, man. Where's it? Do we have a schematic? Okay. Okay, so the magnetics we select then would have those diodes in there already, I guess. Non-isolated, okay. And an isolated, okay. Right, because then you have extra transformer here. Okay. And otherwise you just basically connect it to the output. Okay. Yeah, so with one of the sockets we probably would need to do these diodes manually. And with the other socket, those would be built in. Okay. It still wants center taps though. And I don't know if we can do that. Okay, well, anyway, more than $2.50 I find a bit expensive. I'm not sure we have that budget. So let's look at stupid search results. Because if we look here and we go by pricing, we also have a chip that's 20 cents. Let's take a look at that. So it's AF, so no AT. Okay, 100 volts, 450 milliamp DC input current limit. Sure, we really don't need a lot of power. So inverse limiting, glitch free. Okay, so it needs those connections. Okay, so they have a Zener? No, it's, what's that? A TVS? Okay. Power good. Okay. Power supply. Okay, what does that do? Because if we don't design isolated but non-isolated, I think it becomes a lot easier. Is the music too loud for you guys, or is it okay? I'm gonna turn it down a bit on my side. Music's fine, okay. Under voltage, okay. Yeah, so this chip's $20. So what's the difference? I mean, it doesn't have an internal regulator. That's fine. And I can design a buck converter from I don't know, 50 volts or 60 volts to whatever. But let's take a look at another one. Maybe it adds some nice feature. Okay, this one has a lot more advanced package. 50 cents. Okay. PoE-PD solution with PSR and SSR active clamp flyback converter. Okay, so it does the converting inside. Okay, AF, that's fine. 6, okay. Oh, 1.5 switching current. Yeah, that's fine. EMI reduction with frequency dithering. Whoa, is that another word of saying spread spectrum? Okay. Okay. 13 watt. I mean, we need like 2 watt, maybe 3, right? So that's fine. Small size, high speed switching. Designed for active clamp. Okay, blah blah blah. And secondary side regulation. Okay. 15 milliamp pulse current. Maintain power signature. Okay. So we have 37 to 57 volt coming in. Okay. VCC V bus. Wait, does this do what we want it to do? Okay. Not sure why V bus is here, but sure. Here's a transformer. Okay, let's take more look. I'm sorry if this is a boring stream, but this is really what hardware designing is about. You have to design the hardware. Charge pump output, okay. MOSFET, okay. PD detection and power enable, connect, okay. So what voltages on the output can it do? We'll see. Output of an internal LDO. Connect, okay, sure. Feedback. Source of the PD hot swap MOSFET. It supplies power for flyback converter. Oh, okay. Hiccup period control. What? You want that? Okay, so it can do 105 volts. Good night, Dutchie. What? You're leaving? Oh, Dutch Maker's gonna get some sleep. Stream is not boring, but 4 o'clock here. Okay, good night. Yeah, 57 volts, that's fine. All good. Detection, supply, output, okay, yeah, okay. But does it have an internal... Because that will be ideal if it can do the PUE stuff and also the voltage conversion, so we can get like 5 or even 3.3 volt out. I think I'd do 5 and then maybe an LDO, something like that. Okay, so it runs around 500 kilohertz or 250. Okay. You can set the switching. Okay, sure. Maximum duty cycle. Oh, okay. Yeah, okay, sure. This still doesn't tell me if we can do internal conversion. I guess so. Output voltage versus input voltage. Oh, maybe it does 12 volt. Okay. Oh, you can probably set it. Hey there, Greg. Oh, nice. Okay, blah, monolithic, yeah, integrated PD and flyback power converter, active clamp, P sub, blah, 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 13 watt isolated PUE. Can also support class 4, requiring high power above 13 watt for a short time. Okay, sure. Okay, so you can negotiate a class or a maximum power output. Sure. Why? Oh, you can different classes? Oh, I didn't know they had so many. Okay. Maintain power signal, current limits. DC-DC converter startup. Okay. PWM operation, sure. Yeah, I've designed more buck converters and SEPIC converters and boost converters and stuff like that before, so This all looks fine. Overload, short circuit, over voltage, soft start, good. Switching frequency. The minimum off, yeah, okay. Okay, so 48 volt to 12 volt flyback application circuit. So you'd have 37 to 57 volts here, which would be coming from the socket then, I guess, you know, the RJ45 socket. But then how does it enable or disable the PUE? Does it not have to communicate? I don't know. I don't know how that works. C2, okay. There's a switch here, which activates the flyback converter, I guess. Okay. Looks understandable enough. Isolated supply. I mean, I'm not against doing isolated. I just, you know, don't need to, I think. I'm not sure this one would then support that, but okay. Output voltage. We need a large diode. Non-isolated PD example. Okay. Right, so if we do non-isolated, we have PUE coming in here. Ground, VDD. I'm not sure I understand this diagram, because we have positive here. No, minus. Okay, okay. Okay. And then we only need an inductor. Okay. That's actually pretty good. Or we can do isolated, and then we need a few more components. Okay, let's look at oh, okay, they have a layout schematic. Okay, so this is for the isolated version, I guess. That's not too bad. So they have a clamp here, capacitor, some resistors. Where's the input? Oh, here, VDD. Okay. It's only like 2 amps or 1 amps maximum, so I guess they don't need a lot of copper for that switching node. And then V-bus. Okay, so the isolated part's a bit new for me. I mean, the whole reason diff power I'm building is also non-isolated, because, you know, makes it a lot easier. And again, for diff power, we also don't need it, because you're not going to be connecting another power supply at the other end. Okay, this chip is actually pretty nice. This it has a modern package I like. And it's $50. There's 3,000 in stock. That's also a good sign. Let's add, I don't know, let's add 10 to my cart so I can remember it. Yeah, I actually really like this chip. Do we have building information for that? Okay, yeah, we have a footprint we can import. That's very nice. How do you guys feel about this chip? Yeah, that's the problem with this stuff. I know what they're talking about because I've done lots of buck converters and power circuits and DC circuits, and I kind of enjoy doing those. But yeah, if you don't, there's a lot of learning you need to do. Okay, so let's look at. So let's select this chip for now. Let's look at PUE transformers. Do they have something like that? Power transformers. Remove the stupid search results. Okay. I don't know what we need though. Right. Well, we need something that's in stock and the cheapest. I know what they look like. Let's see if we can find one. I've looked at them before. No. Okay. I'm glad you guys like watching it. I'm always a bit worried about that. It's like maybe this is really boring. I don't know. But this is real world. This is how it goes. Especially learning something I don't know either. I have to do the research, right? Oh yeah, the specifications. Yeah. So what kind of winding do we need, or do they tell us what they use? No, they don't tell us what they use. Huh? Oh wait, this is the wrong datasheet. Wrong. Bad. We need this one. Yes, okay. Yeah, T1. What? Give me an example of T1, please. Let's see if Google knows anything. Oh, they have an EVM user guide. That's good. Okay. Thank you, whatever, Google. So an EVM is basically an evaluation board. And then you can see basically what the manufacturer used to build an example circuit that was also certified or not, or whatever. And this is using the TP whatever. Did we also? Yeah, we're also using the 17. And so basically, this is what we need to replicate, right? So we have the IC here. This is the incoming diode, capacitors, and they have this transformer here. Outgoing diode, I think. And then we have the power. But this circuit, they built it in 34 millimeters by 16 millimeters. So 1.6 centimeters by 3.4 centimeters. That's actually pretty good. That would fit our goals, right? But generally for such an EVM, if they have good documentation, look at that. They have example schematics and stuff like that in there. So now we can see, okay, this is a Zener to clamp over voltage. Well, why would they use a Zener and not a TVS? Don't know. You can see all the capacitors they used and the values. So trans PUE doesn't tell me much yet. But let's see if we can find, because this is T1. But now we can see what they used for T1. T1 is a TWIP, 55 microhenries from Sunlord. I think Google or LCSC would actually have this. So let's see. No, too bad. Okay, then Google will know what it is. JLC PCB. What? Why does JLC PCB? Oh, it doesn't have it in stock. Okay, but we can still look at the values. I think maybe. Or a data sheet. Do we have a data sheet? No. Too bad. Okay. Sunlord data sheet. Okay. Oh, it's one of those generic data sheet. Let's see if we can learn more from the EVM. Okay. Oh wow, they used a dual layer. Yeah, that's never going to be certified. Okay. That's fine. Testing procedure. Okay, so this is the RJ45 socket. This is the magnetics. And I'd like to use a RJ45 socket with magnetic integrated if possible. And then this is probably needed for the Peewee. But the socket we just selected has that built in. But we can do it externally, but, you know. Okay. Oh, they have some efficiencies. So at 0.4 amps. Oh, okay. Yeah, blah, blah, blah. I don't need to know all that. Oh, how warm did it get? Oh, it didn't get very warm. Oh, the transformer is getting warm. Okay. Yeah. Okay. So, let's try and find the specifications for that stupid transformer, because they don't tell us. Yeah, of course. They have it again on JLC PCB, but they don't have it. I need to know the specifications. We can look on the Sunlord website itself, okay? Now we're getting into the real websites. Oh, they have an English. Okay, often the English versions of the website are much worse, but we'll see. Okay, let's try and find it. Nope. Okay, let's try and strip some stuff off of the that's not doing anything. Okay. Nope. Okay, can we even get a TWPEP? No. Okay. Can we get a TWPEP on here? No. Okay. Okay, let's go back to that stupid data sheet we found. Oh wait, what is this? Oh, okay, this is an eval board by a different company. Wait, this looks very familiar. Did they copy the chip? Wait. Where is that photo? There it is. So this is the 3-peak one. No. Okay, and this is the monolithic power one. It's not exactly the same. But, I mean, having the capacitor here and then these two resistors and then these all here, that looks suspiciously the same. And then, I mean, these are also exactly in the same spot. And then, okay, here's an extra inductor. Not sure what that's for, but sure. Okay. Oh, wait, we also have the inductor here. I think they copied it. Oh, they swapped this large capacitor and this small one. They swapped it around. And then here we have this capacitor and large diode and stuff like that. Yeah, they. Okay, so 3Peak copied a design from Monolithic Power Systems. Wow. How much is an MP whatever? Oh, they don't have it. Okay. How much is an MP whatever? Yeah, the monolithic power, the blah blah blah. Go away. Go away. I don't care. Okay, I'm in the Netherlands, and then often the page is gone. Oh, wait, it's not. Okay. So one of these is €1.30, or €1. Okay, well, that's not too bad. But I don't mind using the fake one. I mean, this is just too familiar. Okay, let's see what inductor they used. Specifications are also the same, I think. Yeah. Okay, what inductor did you guys use? What was the name for the inductor? It doesn't say over here. Okay. An MPL. Oh no, I need EPC T1. T1. Okay, T1. Oh, look at that. They also used the stupid TWEP. 55 microhenries. Okay. Okay, now we know more. Did the other sheet also tell us this? No, it did not. Okay. We need a 2-to-1 transformer ratio. Good. And we need 55 microhenries. That is the same. So, yeah. And they also suggest the same inductor. So, it's the same chip in the same circuit. But they say you can also use a Gold River blah blah blah. Does LCSC have the Gold River blah blah blah? It does not. God damn it. What is this? Karaoke version? Actually, I think we now kind of know enough. Let's go to the power transformers. We need a ratio of 2-to-1. No, it's okay. 2-to-1. 2-to-1. Okay. And we need an inductance. Oh god. Okay, this doesn't work. Okay. Let's do it another way. We need 55. How much do we need? 55 microhenries. Okay. We don't have that. What do you mean? Okay, let's go with 50. Sure, that looks kind of correct. No, so basically, normally you go off the data sheet, and if you calculate, then they'll have a section in here. For the transformer, overload, blot, typical application. I kind of just wanted to check the price of a transformer. They have a selecting a transformer in here, and then they give you all kinds of difficult equations. Typical for this, you need a 2-to-1 winding ratio for 12 volt output. Blah blah blah. Okay, blah blah. V out compensation. Okay, but I kind of just wanted to check how much a transformer was, because I know how much inductors are, and if transformers aren't too much more, we can build an isolated version. But if transformers are way more, I don't want to build an isolated version, right? So let's clear this, and we need a 2-to-1 in a ratio, I guess. I don't really know. I just wanted to have an indication of how much a transformer is, because I don't know. Here we have a 9.5 U1. That's probably way too low. That's 70 bucks. But maybe if we run a higher voltage, we need a different ratio? How does that work? I know how it works with a buck or boost or sepic or whatever. What kind of 63 microhenries can we get? 1-to-1, okay. Oh, this is from Hanron. That's also where the socket is from. Does it say what voltage its output is? No, it doesn't, right? Yeah, but these are, well, okay, 38 cents, that's okay. Let's see what else I can get, because there's only one, so that's a bit odd. Okay. These are, okay, yeah, okay, the C&D.Tech I remember as a brand. Yeah, but I'm not sure. I mean, I think the output voltage depends on the microhenries and then the windings and then the switching speed. So it becomes complicated quickly. We could try and ask Google. Let's see what AI thinks. That's how you do things nowadays, right? So Google, with a PUE IC, if I want 5 volt output, what kind of transformer do I need? I need winding, how do you call that? Windings, I guess? Help. Now AI is going to figure it out for me. Oh, okay. We need a primary inductor between 30 and 50 microhenries. Winding ratio, okay. The transformer will generally have a primary to secondary turns, 6-to-1, 7-to-1, okay. Okay, why there's an advanced power side regulation. You do not need an auxiliary winding, okay. Okay, sure. It's getting all this from 3-peak, so that's good. Switching frequency, yes. Coil, oh, very expensive. Even more expensive, okay.
What are you afraid of?
Now, I know you shouldn't trust the AIs, that's fine. But, let's have it calculate. Please calculate using the formula in the datasheet. Don't just make it up. I want about 5 volt with 1 amp output. Yeah, I could use Claude, sure. I don't know, we're just having fun. Don't worry. Thinking a little longer, that's good. Okay, 1.5 amp, okay. Okay, 250 kilohertz, sure. Yeah, okay, it's using a TI formula for some reason. The primary inductance, now we suddenly need 200 microhenries. So many hours wasted. Don't do it. No, okay. Let's listen to it for now. Let's say we want 200 microhenries. Let's go back to the power transformers. It feels like a lot, but okay. 200. 2 results. Okay. Typically, yes. Why 200? The example board uses 50. Please explain. Oh, it's just saying like, oh, you can go with 52 if you want. Yeah, I suggested 200, but if you want 50, that's fine too. A 6:1 transformer ratio. Okay, how much ratio is this? 1.25. Okay. Yeah, I can be so dumb. Because now I still don't know anything. Right? I mean, should I use 1 to 2 or 1 to 6? 1 to 4? I have no idea. Gemini doesn't know anything either. Anyway, what does this do? How many? Oh, this has 2 windings. We don't need one with more windings, so we at least know that. Yeah, I'm not gonna go through that formula on stream. That's gonna break my brain. Can we say 1 winding? Primary windings 1. Okay. Did we break it? Okay. Can we say shielded? Nope, not really. Okay. She gave me a circuit design. I had questions. Yeah, I use it sometimes to spar with it, but you need to bring your own knowledge, because otherwise it's going to suggest all kinds of crap. And I'm like, what? That will never work. Yeah, but those probably use like the cheapest of the components possible, and I don't like that either. I think having Handrun, which also makes a PLC transform. Okay, the socket itself, that's a good indication. Let's just ask more to, you know, what. Okay, let's ask Google. What would happen? Because this one's cheapest. Okay. What would happen if I used a with is a critical design error for step down PUE to 5 volt. Okay. Duty cycle collect. Okay, that I can understand. Okay, so we need we need more windings. For 5 volt, we want 6:1 to 7:1 ratio. Okay, let's see if we can find one that's fairly cheap. 1 to 2, 1.11 to 5. $0.37. What? Two to 1. This one looks fancy. It's 70 cents. Okay. Well, 9.5 microhenries. That's way too low. Yeah, I don't think so. One to 4, 25 microhenries. Oh, wow. I don't like that. Okay, let's remove this. Okay, we're back to trying to find out how many windings this had. Or ratio or what. Oh, we knew the ratio. Wait. 2 to 1. Right. But this was for 12 volt out. Now 12 volt out isn't the worst. I guess we could make that work and then down convert it ourselves. But if we could get 5 volt out, directly, that would be better. Oh, they did? Okay, I didn't see that before. Okay. So, do we have any Sunlord? No, I guess they don't stock those at LCSE. Oh, now I understand. If you have multiple there, it's multiple windings. Okay. Yeah, we only need a single winding. What is a secondary side? Oh, no. Voltage clamp, 5 volt. Oh, okay. So what does this do? What, this has 2, what? I don't understand. So it has a primary winding and 2 secondary windings, I guess. Oh, this one has all the windings. A flyback transformer for PUE applications. Exactly, Philip. A test is working. I think I've seen this one before. Do we actually need a flyback transformer? we might actually need a flyback transformer. Where is our data sheet? Because it's a flyback converter, so... But there's only one coil here, isn't there? Anyway, how much is this? $50. Yeah. Or 50 cents. I don't know. I think I need to do more research. And on here, they didn't use one of those fancy things. They used a thing I like. Oh, okay, this one has a lot of legs. Did this one also have a lot of legs? Yeah, this one also has 8 legs. Test 2. Okay. But then... Oh, there's another inductor here, sure. But then this only has 4 connections. So are they just not using... Oh, okay. So looking at the copper layout, this is 2 connections, this is 2 connections, this is 2 connections, and these are each 1 connection. This is just not connected. Oh, okay. No worries, Rob. Okay. This is no copper. Oh. Do they have a... Oh, their inductor got a lot warmer. Or a transformer. Do they have a layout schematic? Yeah, okay. They have a layout. Yeah, let's do the same thing. So this is connected to ground. Output, input, feedback or something, nothing. Okay. So they actually do need 8 connections. Yeah, okay. We can try and search the number, but we're going to get the same port that we already can't really do anything with. So S2104008. S210210408. Did I get that right? S2104008. Yeah, nope. No, I don't think PUE is ever going to be integrated into that, because it's going to cost way too much and too much board space and various reasons. Use an external PUE extractor. Yeah. So this power transformer would probably be correct, because this is a flyback transformer, and no, wait, this doesn't make sense, does it? I don't know. Yeah, this transformer is also quite big. I'd rather get something smaller, but I'm just trying to find what is the right component at all. Right? But on the evaluation boards, we see them using these nicer, smaller packages, like this. Okay, so what does this do? 3 to 15. Okay, what? What do you mean? Translate to English. Provides an unregulated power supply solution with a 3.3 volt or 5 volt input, 3.15 volt output. Wouldn't that be the other way around? Okay. V in, V out. I don't know what that means. Output voltage, okay. 200 milliamps. That's a bit low, isn't it? V in, V out. It's both 5 volt. Okay. Yeah, I don't know, Foxionaire. I'd look at diff power for that, but I mean, if you look at the prices here already, that's not boding well. 3.8 watts. Okay, so this can do 750 milliamps. Okay. It's only 6 pins. I don't know how this works. Okay, let's let go of the secondary side blah. What does this do? I don't know. This requires more research. Because I have no idea what I'm looking for. I had hoped... Oh, this is an SMD version. Okay. I had hoped we could find the example ones in here. But that is not the case. And without knowing what the examples are, and you know... 24-hour live stream. No. We're designing a PUE input circuit with output of 5 volts, or at least we're trying. And we're trying to understand how transformers work. Because I don't actually know. Oh, this has 10 legs. What does that do? Oh, this is also a flyback transformer. Okay. Oh, this one is for 12 volt output. Okay. Yeah, but I think this is way more than we need. Yeah, we don't need 12 volt 2.1 amp output. Wait, yeah, okay. What was it? Yeah. Yeah, I think I still need to wrap my head around that. Okay, we're going to search differently. We're going to search by how many they have in stock. Oh, they have a very expensive Coilcraft. Okay, let's look at this guy. 200 microhenries, 1 to 2.5. Okay. push-pull. Oh, it's for a certain controller. Oh. I don't know. I also don't know if I need a flyback controller or not, because our data sheet doesn't tell us. Yeah, blah, blah, blah. Yeah, I get what it does. I just don't know, or I haven't ever calculated what I need, and then what corresponds to that component-wise. I think I'm gonna take a good primary. Okay. Take a good look at that. Not on a stream. But at least we found this chip. This IC is pretty good. They have a lot of them, and it's only 50 cents for 1,000, so I can generally get it for that. Yeah. Yeah, I mean, this I'll get from, designing normal switching regulators. But I don't understand, like, how many coils do we need or whatever. I think we only need a primary and a secondary. So one set. We don't need secondary power coils. I know WeBench, yeah. I just like looking at components. Microhenries, V out, okay. The Coilcraft one, oh, it doesn't have a data sheet. Aw. Yeah, I don't know. I think I'm gonna do some research on that offline. As I said, I like this chip, and I'll look into it a bit more this week, and then maybe next week we can do some more design work actually in the schematics. And I'll also try and see if they... Oh, see, this is a TVS. That makes sense. This makes sense. Yes. Why is the evaluation board using a Zener? What? That makes no sense. D1, D2. What is D2? D2 isn't on here. C? C. Oh, D2. TVS diode. Then why did you call it a Zener, you idiot? Okay. As I was saying before, it makes no sense to put a Zener here, or at least not in normal applications. A TVS, yes. Did they just copy it badly from this guy? Let's see. D2. Yeah, okay, well, this one just doesn't say that. Okay. They just made a bad schematic. Are we surprised? We'll make a better schematic. No worries. Yeah, okay, but don't call it a Zener. A TVS has a very different... Well, okay, the function is somewhat the same, but the reaction speed is very different than the application where you use it. Is very, it's very different. So yeah. But the TVS makes perfect sense here. That's fine. I would put a TVS there too. And the rest of the components aren't that complicated. Is D1? Okay, yeah, so that's a normal Schottky. I mean, the rest is pretty simple. I just don't understand transformers. So I need to learn about transformers this week, and then we'll continue. Yeah, but I think the MP1817 is the IC that 3Peak based this one on pretty clearly, right? So we can find, or we can digest from both data sheets, because this and this is basically the same. Yeah, so we let's save this data sheet to downloads. Six movies about Transformers, mostly Autobots. Yeah. But I mean, the rest of the circuit I can understand. So we have a TVS, we have a small cap here to, for hot plugging stuff. Then we have the input, we have some caps and resistors, capacitors. I'm not sure what this inductor does, but I believe it has an internal regulator, so it doesn't need a secondary winding. Okay, that's fine. More capacitors. Some feedback probably. And then here we have a Schottky capacitor, okay. Output capacitors, yeah. That's okay. Oh, we have a capacitor bridging. What is C12A? C12A. Ah, okay. It's for, I guess ESD? Yeah. But it's only 1 nanofarad, 2000 volts, so, yeah. We have an A and a B and a C, okay. Where are those? Oh. C2A, C2B, C2C? Oh, 12, okay. Sure. Okay. C, can I search these? Yeah. Okay. Oh, here they are. Okay, they're specially... Normally I put those on a shield. Does this one also have that? Yeah, it also has that. Okay. But then where are they? C2A, C2B, C2C. Okay. C2A, C2B, C2C. Oh, 12. 12. I keep getting it wrong. Where is the 12? This is C12A. C12B? I don't see them. Okay. No, don't exist. Do they exist? No. C12A. Yeah, probably, yeah. But that's what I was saying earlier. The data sheet of the IC tells you the theoretical stuff, but I really like looking at the evaluation boards to see what they actually build and how it goes together to, well, to understand the circuit and then learn about it and then design my own version of it with, how I interpret it for my application, right? Yeah. Yeah, but it's 2000 volts because I think it's mostly ESD and drain related, right? So if there would be a capacitance difference between the two sides of the transformer coils, I think it's just a drain between those two. So it's not a DC coupling, but it's an AC bridge, I guess, or AC coupling. To make sure the two sides don't drift apart too much. Yeah, otherwise you wouldn't need this big cap. I mean, C1A and C1B, let's see what voltages those are. Those are probably 100 volts. C1A, yeah, 100 volt, okay, they're 1210s. Yeah, I use 1210s more often. Because like for power diff, I also use 55 volt, so my ceramics are also 100 volts. Makes sense. Yeah, so we have an inductor. That's a massive DCR. Okay. Huh. So what does let me look in the data sheet. Where's the inductor? There is no inductor. What? Yeah, it's okay. No, but what is the inductor connected to? Do we have an inductor here? We have an inductor here. VBus. Okay, what does VBus do? Let's go to the top. La 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 la. Where's my pins? Pins. VBus. Source of the PD hot swap MOSFET. It supplies power for flyback converter. Okay. Sure. Doesn't tell me what it does. Does it generate some kind of internal voltage? Blah, 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 blah. Okay. Sure, blah. VBus, okay, over voltage clamp. You're not telling me what it does. Dual blah. No, it doesn't have a USB connector. I think they just reused the name, which is stupid. And the inductor is like completely missing in this data sheet. So I mean, what? Where is it? Okay, let's see if we can find an MP. The MP 1817 data sheet. Maybe that tells us more. Oh wait, no, this one. Okay. Ultra small blah 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 PUE PD solution. Okay, yeah. Okay, we can do a flyback circuit. Okay. Oh, look, the IC looks exactly the same. Ultra small transformers. We like that. We like small transformers. Yes. Oh, we also like this. Oh wow, they actually did some measurements here. Okay. Let's see. What is vertical? Okay, so they call it a frequency dither, but it's basically spread spectrum. So if you do these tests, which I also do on my boards, if you don't have spread spectrum, if you have a peak, it's basically one frequency and it peaks at a certain value. And what they do, they basically jitter, or, well, they call it jittering, but spread the spectrum that it's functioning at so that peak becomes more of a valley, which is, so, yeah, it's more dispersed, the energy is more dispersed, so the peak is actually lower but wider, but because of that you can still, you can see it here, right? So you see this peak over here, it's still there, they didn't fix it, but because they made it wider, it's now below the threshold because the energy in the peak itself is lower. I hope that makes sense. So if you want to do anything with EMI testing and stuff like that, it's good to have spread spectrum or jitter, whatever they call it here. Jitter, reduced frequency jittering. Sure. Yeah. But that's good. I mean, we selected a very nice IC. It's based on a very nice IC. Okay, let's find the data sheet for this guy. Data sheet. Okay. V-bus, capacitor, transformer. Okay. Then why is there an inductor here? Where does it go? Power ground, snubber. Okay. And why is it called V-bus? Yeah, okay, this is exactly the same as the other datasheet said. Inductor. Input yeah, okay. Really? There's no other inductor named in this datasheet? Oh. So why is there an inductor on the evaluation board? Yeah, okay. 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 All good. I like this IC. Good. Soft start. Yeah, yeah, okay. Okay. Switching frequency. TVS, yes, good. PD input capacitor. Sure. Okay. Selecting the transformer, we can also read this later. Yes, okay. Yeah, this recommended layout does not have an inductor. Same transformers. This actually makes more sense than this evaluation board. So if you look at this evaluation board, yeah, okay, they used a different size. This is still a good loop. Okay, never mind. But this is better. This feels better. Anyway, okay, no inductor. Gemini created the... No, but this is the datasheet from Monolithic Power. So, VBus. 2 capacitors. Okay. Sure. VBus. 2 capacitors. No inductors. Oh, wait. We have a different inductor number. So this is for Vout 12 volt. For active clamp, PSR flyback. Okay. Okay. Let's go down. To 5 volt. Oh! What kind of transformer is this? Yeah, maybe. I don't know. Okay. Shit. It doesn't tell us anything. Karaoke Vision. What? It is from Monolithic Power. Oh, the trap has a 4.8 to 1, 55 microhenries. Who is telling me this? Yes, yes. Cannot find a datasheet vendor for this transformer. Exactly. This is also our problem. Hi. Okay, yes. Yeah, I get that. Okay. Anyway, we now know more. We want a 4.8 to 1, 55 microhenry. Well, LCSC doesn't have that. But that's good. See, now we find out more through this datasheet, which is what they copied this IC from. That's good. Okay, here we also have only one coupling. Okay, we want a 47. Okay, that's fine. For we can get large packages at 5 volt. That's fine, or 5 volt. Okay, we have a suggested diode. That's good. That's okay. A little snubber, I guess. Or anti-hysteresis. Okay, switching frequency. All makes sense. Yeah, this makes sense. Okay, yeah. Okay, detection. I'm liking this IC more and more. This I can understand. Okay, that's fine. Oh, they have more versions. Let's see what this does. Holy. Active clamp and a sync SSR flight. What the? I don't think we need that. It looks more complicated. It also does 5 volt at 12 watt. What is sync SSR flight? I don't know what that does. Oh, SSR is a solid state relay. Okay. So this is a relay. Is it to decouple the output even more? Okay. I don't know. I'm scrolling. Okay, it's a bit slow. Okay. Right. Okay. So I think we'd mostly follow this example, right? And I don't think this example is in the copied data sheet. Let me check. There's no examples in the copied data sheet. Oh wait, this is the EVM. Okay, sorry. Okay, typical, isolated. Yeah, no, okay. So it's good we found the origin chip data sheet, because it has more information which is useful for us, because we can basically copy this circuit and tune it to the components we can find ourselves. to get a active clamp PSR flyback, blah, blah, blah. 5 volt at 12 watts. We don't need 12 watts. I mean, probably the transformer has something to do with that. But we want a, what was it? 4.8 to 1. Do we have that? 4.8. I guess. Apply. It's big. It's huge. It's also 25 microhenries. We don't want that either. Is there a different transformer? Power transformers. No, we were here already. Yeah, I don't know. No clue. Way too big. Okay, don't know. Anyway, I think I'm gonna call it for today because I'm also getting a bit tired. Yeah, maybe. I don't know where that magical inductor appeared from. Why it's on the evaluation boards? Because it's also on the. Is it also on the monolithic one? Yeah, it's also on the monolith. It's also on this one, right? So the original vendor also has this inductor here. I guess it's to provide filtering, not so much dampening, but an inductor filters. And what they have here is a CLC filter. So, so they have a capacitor, inductor, capacitor, so CLC. So they have a CLC filter before V-bus goes into the flyback coil, or into the coil. That might be for EMI compliance, right? So maybe V-bus is a bit noisy otherwise, and they dampen the noise, but it's not on the eval board. Oh, but it is on the eval board. It is. Okay. So they dampen the noise before it goes into the transformer. And it doesn't have to be a large inductor. That's fine. We can get those pretty cheap. And they did test the eval board here from Monolithic Power, as you can see. And they probably couldn't get the right results. Yeah, so they probably couldn't get the right results. So they added a inductor or a CLC filter with the inductor in there to their eval board. Radiated, yeah, conducted. Okay, yeah. To basically dampen it down so they could pass. But then they never spoke about it again. I don't like that. Oh, why? That's probably it. The V-bus is switching at a certain frequency. And it's enough to have capacitors there. Inductor. Yeah, right. No mention of it whatsoever. Bastards. And here it just doesn't exist. Nope. No CLC filter here. What are you talking about? All is fine. You don't need that. Nope, not here. No CLC filter. Nope. Do they talk about a CLC? Nope. Do they talk about a filter? Okay, that's for V out. Do they even talk about VUSB? No. What? Oh, VBus. Okay. Okay. The pin internal LDO from VBus. Okay, so they say VBus is an LDO, so it generates some internal voltage, so you don't need multiple windings. I think we read that before. Okay, supplies power for the flyback converter. Sure. Okay, discharge the VBus, regulation. When PD is the input starts to power, okay, charge the bulk capacitor on VBus. The inverse current limit function. Okay, so it already does inverse currenting, limiting. Okay. VBus over voltage. Okay. Exceeds UVLO. Okay. UVLO is under voltage lockout. Can detect primary run. Okay. Over temperature. Okay. Maximum sync. Okay. Keep input hot swapped loop between the PD input capacitor, VDD, VBus pin, and VBus capacitor assured. Okay, but it still doesn't tell me what VBus does. They're just not going to tell me. Okay, so I think they call it a LDO, but I'm starting to get the suspicion there might be a switching regulator in there, and it probably threw out too much EMI or conductive noise or both, and they put a CLC filter on there to dampen that noise and pass EMI. And then never talked about it again. You think VBus is the PUE input power? No, it's to do something with the coil. Stupid example. Yeah, this datasheet's better. So if we look at VBus, I believe VBus comes out here. Oh wait, no, it's not great. Yeah. I don't know actually. Let's look at our 5-volt example. Wow, this is slow. I don't know why this is so slow. Okay, 5-volt example. So it's not connected to the input. The switching is over here, so switch output's here. I guess it provides the positive output. I don't know. I don't know either. I think the detection circuit's on this side, so VDD. Oh, that's the input. No, it's not. It's not directly connected, but I think it's a voltage the coil uses, and then the switching node is connected to the other part of the coil, right? And then after this, it gets rectified. But yeah, it's probably switching at the switching frequency together with the switching node. And as I said, they probably found during EMI testing that it was generating too much noise. And they put an inductor on there, or a CLC filter on there to filter out that noise. Could be that that the noise from SW, so the switching node, made it back into the VBus output, and that created too much noise. That's possible. So it might create noise inside of the IC because it gets feedback from the switching node. It's okay, I guess. But whatever, as long as we understand what it does, yeah, we can just copy that. See, again, this is why I tell everyone who asks me, look at the evaluation boards. There's a lot of secrets hidden in the evaluation boards. Where is the evaluation board here? Oh, here. Because without this evaluation board, we would have never known. Because it just doesn't exist in the datasheet. Which is bad. Which is very bad. They should just tell you about it. But yeah. The Quinn LED evaluation board. Yeah, no. I'm working on lots of stuff, but this week a bit less. This week I did other stuff. I moved over my domains. I created a new website. Things like that. But I did some work on the DigNext 4. I guess we could do a secret. We could do a secret. Do you want to see the DigNext 4? Can I do that? I guess I can do that. Or the current iteration of the DigNext 4. It's very much in development. It's not done. It's like nowhere near done. So, okay, let me how do I do this? Okay, I put it over here, I think. And now I need to share a screen. There. Okay. We've got a PCB here. It's a nice... why is this so big? What? No, go away. Okay. No clue. We've got some output stages here. Input connector here. I'll show it in 3D in a second. You'll understand more. We've got some mysterious connector here and mysterious IC here. I'll explain it in the 3D view. We've got some 5-volt conversion going on here. And some output stages for data. Then we've got some Ethernet. We've got a nice Ethernet connector with a nice Ethernet IC. Again, this is all work in progress. Don't pay any attention to it. We've got some USB power input, which does some DC-DC conversion, but we also have other DC-DC conversion going on here. And we've got some lines running in here. Those still need to be optimized. Anyway, we'll go to the 3D view. Hold on. It's struggling with the 3D view. What's going on? Why is this taking so long? Okay, there we go. 3D view. Do I have? No. No. There. Yes. Need more RAM. No, this has 64 gigs of RAM. Let me check. No, we're using 18.7 gigs of RAM. And we're at 15% CPU utilization. Need more GPUs. It has a 5070 Ti. The reload time is 10.9 seconds. Oh, okay. Okay, now that's fine. Faster RAM. Yeah, maybe. It's at 3600. So, it is a 5900X. I mean, it's no slouch. It's okay. It's fine for a streaming PC. More cores. It has 12 cores. Alt 3? What the hell? No, what? Sometimes my 3D view won't pop to the front. Oh, okay. No, I don't have that issue. But so this is the current iteration. Again, this is very much a work in progress. Could turn out completely different. So we got the large input connectors. I also use in the Dig Quad because I think those are just very nice to connect large cables to. We got 4 button inputs, 2 ground terminals to short those buttons with. We got a relay connector, like this guy, right? Where am I? There. Come on. So a relay, so you can use the same relay connector from, I don't have any, oh yeah, from the Dignex 2. Same relay connector, you just plug in this plug-in here. It provides 5-volt trigger and ground. So you can just plug in your relay like that. So very easy relay connection. Then it has 6 power outputs instead of 3 that the Dignex 2 has. The idea is to have 4 times 4 amp and 2 times 10 amp. So you can do front, middle, end injections. But maybe I'll allow having extra 10 amp fuses in some of them, because I use different MOSFETs for that, because one handles up to 5 amps and the other handles up to 10 amps. So you need a different IC for that. We've got some TVS protection. Hey, huh? Anyway, we've got our button circuits. We got our load switch here for the output. Then we've got our USB-C, which has its own switching regulator, so we can have dual power input. We've got our Ethernet, our negative input socket. We've got our QEXP port and our I2C port. We have another power circuit here for the main power input, and then we have some load switches to switch between those basically. We've got the ESP external antenna, a socket here for a temperature sensor, which never realized, but that's fine. Our output stages with ESD and over voltage protection. Yeah. Oh, and our mystery IC. This is an I2C expander. Because the ESP32 with Ethernet does not have enough pins to individually switch 6 channels. And I like to have them individually switchable. So we're using an I2C expander, which then can individually switch each output if you wanted to. Normally you'll probably switch them all at the same time. That's fine. It's also connected to the relay output. And then there's no LEDs on this board because I just couldn't fit them in there. But I do like the LEDs on the Dignex 2 having a blown fuse indicator per output and a relay indicator per output, for if software catches up and you can do per output on and off switching. So the idea is to have a separate board. 0201, no, because you'd still interrupt power planes and things like that. And I like having my power planes on the top, because having thicker copper on the top is cheaper than having thicker copper inside the board. So there's a trade-off there. I could fit it on there, but then I'd interrupt the top power plane, and I'd rather not do that, right? And you'd have to have vias and signal runs, and you could do that on internal layers, but you'd still interrupt power planes and things like that. And since this needs to do like 30 to 40 amps, designing around the power capacity becomes more important. Yeah, so the idea is that we'll have these connectors here, so this guy and this guy, and that there will be a PCB inside of the, because it'll be in a nice shell, there will be a plug-in PCB that plugs into this connector, and that will have all the components for the fuse indicators and the power outputs. Nothing can be more important than the pink LEDs. Yeah, sorry. It can generate a lot of pink output LEDs. But yeah, it'll have a top board which you can remove to replace the fuses. It's just pulling it out. Which will have all the LEDs and status indicators and things like that. So that will keep it serviceable, so people can still replace their fuses themselves, but also keep it manufacturable and the power requirements and things like that, right? So yeah. And I'm still, as I said, still working on the design. Oh, we're back here, okay. Because if you look here, we have a full ground plane, of course, on the second layer. But currently I'm going to test with 6 layers. So we have an internal layer here, internal layer here, internal layer here, but I use this for signal. And then another internal layer, or external layer for yeah, basically these all do power. So we have basically four power layers to try and get all that current across. Yeah, exactly. Yeah, so on the output, I didn't actually tell you. Do we get 3D view? No. Yeah. So the output connectors, the idea I currently have is just one giant wall. But it'll be just like on the Dig Next 2. We have the red connectors, right? So those are the positive. Oh, I actually... Did I mirror it from the Dig Next 2? I guess I did. I might need to change that. Okay, not sure yet. If I want to... If I care that now the outputs are on the right and the ground's on the left. That just worked out better. I guess I could swap the layout, but I don't know. We'll see. It's just a prototype for now. Right, so we have 3 ground terminals, which would be black, or 6 ground terminals, which would be black. We have 4 signal terminals in the middle, which would be green. And then we have 6 outputs here, which would be the switched and fused positive outputs, which would be red. So once it's in the case, yeah, it's all color-coded. So it's very clear what is what. I think I know why this happened, because this is the same layout I use on the Dig Quad. So if we look at a Dig Quad, a pink case, if you're going to pay for it, if you look at the Dig Quad, I think this is why the positive layout is like that, because there I also did it like that. Okay. I can still change that around. I don't know. I think I'm going to order prototypes for this sometime soon. And we can test the power throughput on the stream and stuff like that. Where does this fit in the line of products? So the Dig Quad is more of a DIY board. So this is one of the revisions I'm working on. It's not released yet. I've changed stuff again. Prototypes are on their way. So it's more of a DIY board, doesn't come with a case, and it's meant to integrate into your own project box, and it has a replaceable ESP32 and things like that, right? It's very versatile, etc. And it's not so much that the Dig Next lineup isn't versatile, but it's different type of product. This is more meant for people who want to buy an enclosed controller that's just done. They can hook up a power supply and don't need to build a whole box around it and mess with stuff like that. And it has some next generation circuits in there in regards to power generation, DC-DC fusing. I mean, it has like a broken fuse indicator and a relay per output, which the Dig Quad doesn't have. So yeah, it has some more advanced circuitry in there, and it breaks from the mold or the form factor that the Dig Uno and Quad line have, right? I can't really mess with that too much. So this is, you know, meant as a more consumer facing with a nice case and things like that. Oh, we've got the pink case fundraising here from Draadstaal with €6, and then Philip came in for pink case for €5. Okay, maybe I will ask the factory if we can do a limited pink run. If the time ever comes, I'll talk with Johnny, and I'll select the shade of pink he likes best. And then maybe we can run some through the mold. I just don't know how many they need to flush out before it's white again. I guess we then get off-white versions, which have a little bit of pink in there. Because the problem is, if you put a different color in your mold, you then need to flush it out. The same like your 3D printer. If you print a different color, it then needs to flush a whole bunch of filament before that color is gone again and it switched colors, right? You $20 extra for a pink case. Yeah, but the problem is I probably need to give me more pink. Okay. Yeah, I don't know. Okay, I'll discuss it with them, but I don't know if that's an option. If I need to make like 100, of which 50 are off pink, like 25 before, 50 are good pink, and then 25 after are off pink again, it's gonna be expensive. Breast Cancer Awareness October. Okay. Yeah, I'll discuss it. I will discuss it with them. I will. But, it is a great idea, that's true. And there's just a lot of cost involved. It's not as simple as pushing a few pink ones through. You can sell the off pink. Yeah, maybe I'll just do a batch of 100, and then you can get anywhere from white to off pink to pink, and whatever type you get. Make it a Discord special. Sure. You missed a lot, Timbo. You'd have to go back, but it's like 2.5 hours of looking at PUE stuff and how to design it. So it might be a bit boring, but that's what design is. $5 discount. Yeah, discount from the higher price, right? Do them all pink. No, and such a mold is like 10,000 euros. So if I'd ask $1 for the case, I need to sell 10,000. Let that number sink in. Before I break even on the molds, right? So I don't. Yeah, I don't think I can do just the pink version. Sorry. I mean, on the dig next, we haven't anywhere close to broken even yet. It's a multi-year investment to do that controller and get it back, right? No, yeah, so a lot of vendors make a case and then do 10 different products in there. I'm not that good. And I like custom fit cases for the purpose, because then you have to compromise your product design to fit the case you have. But I'd rather not compromise the design and fit a case around it. So it's a different approach. But yeah, it means you have to sell a lot. I don't offset that much. Let's say the dig next to, I maybe do 1,000, 1,500 a year if it's a good year. I hope. It's the first year, so I don't know. Yeah, but it's a multi-year investment. That's okay. Yeah, I designed the product to be the best product I can make the product be, and not, be mediocre at what it's supposed to do because it's cheaper. Designing a 3D printed case is easy. I've done that for like the Diff Advanced and other stuff, so that's not the point. But having the cases printed and be good is, I haven't found a good supplier for that yet in China. And then there's shipping and yeah. You have 10. Thank you, Rich Jager. That's nice. But yeah, I've looked at, doing 3D printed designed cases and selling them with the boards. Yeah, I haven't been able to figure that out yet. And it's about volume, right? If I know I'm going to sell 5,000 in its lifetime, I can do injection molding. That's okay. If I think I'm going to sell 500 or 250 to 500 a year, I can't do a custom case for that. That's why the analog boards, for instance, they have a aluminium case, and those are extruded aluminium. Do I have one here? No. But those are more expensive to buy, but then I can do lower volumes of them. So if I make a product which I think or hope is going to be a higher volume, I can do a custom plastic molded case. If I don't think so, It's either no case or a prefab case, or what, like an aluminium extrusion or something like that. Yeah, exactly, Foxionaire. Yeah, that's it. Yeah. So yeah, it's choices, right? Yeah. I need to predict how much we're going to sell and then base the design around that, because I can't just make custom plastic molded cases for everything, because I'll be bankrupt in in a year. And that's why I also think the Dig Uno and Quad lineup, and Octa in that manner, deserve to exist next to Dig Next, right? It might cannibalize each other a little bit, but you know. Yeah, I'm going to go too. So, Philip, your exit call is right on time. I thank you all for watching and suffering through with me through selecting components. Next time we'll continue. Thanks, guys. Bye-bye.